Today we're going to do two things, one of them really quick here at the top, and the one I'm going to do with you at the top is just some special factoring that's really similar to factoring a quadratic, but we're going to actually factor some quartic expressions, and then after that we're going to get into how to solve some polynomial equations. You will need your graphing calculator today, or if you don't have that, I'm going to show you the Desmos program on the computer. Okay, so these questions are of the format. These are all quartic expressions. That means they're to the fourth power. So this is going to look really similar to a quadratic. So normally we have ax squared plus bx, there's no power there, plus c. So this is a quartic expression in that same format. So this is to the fourth, this is squared, this is a plain number. No third powers, nothing like that when you're doing these problems. And so what you want to work with is the same thing we did with the quadratic. Multiply AC, add to b. And I'll go through that with you really quick. So in any of these questions, and it's not going to happen on the first one or the last one, but it will happen in the middle. Before you start any of these problems, you should always see if you could take out a greatest common factor, either a number or a variable, but always do that if you're trying to factor. And on this question, I don't have anything like that. So here's how this works. The a value here would just be 1. So I'm going to do 1 times negative 27. So I need two numbers that when I multiply them, I get negative 27. Same two numbers, I add them, I get the number in the middle, the b value, which is negative 6. Okay, now here is literally the only difference between factoring a quadratic in that format and a quartic. This is x to the fourth. So normally when we start these factors out, we write x. The only difference is you're just going to write x squared. That's literally the only difference. So x squared times x squared gives you x to the fourth. Now, you're going to fill in the other parts of the factors with the two numbers that fit these requirements. So I would say to you 9 times negative 3, negative 9 plus 3. So make one of these a minus 9, one of these a plus 3. Now, sometimes these can be factored further down. So now what I have here, this is a quadratic and this is a difference of squares. So this, in factoring a quadratic, same process, but this is factors of negative 9 that add up to 0. So that actual first term there can be further factored, x minus 3, x plus 3. Now x squared plus 3, that's not a difference of squares, so that's just going to be your other factor. And then this is your completely factored form of that quartic. Okay, so I'm going to repeat this process. So first thing you got to notice here, each one of these numbers, 3, 6, 45, they're all divisible by 3. So I'm going to take a 3 out in front. If you don't do this first, this process will not work. So make sure you always check for a greatest common factor. So this will just be x to the fourth, 2x squared, and 45 divided by 3 is 15. Okay, so keep the 3 out in front. Now, I'm just focusing on what's the parentheses. I need to multiply 1 times negative 15, and I want to add to get 2. So I'm going to start each of the factors out with an x squared, and those two numbers we're going to use negative 3 and 5 would multiply to give you negative 15. Negative 3 plus 5 is 2. So make one of them a minus 3. One of them a plus 5. Neither one of these numbers, well, this is a plus, so I wouldn't look at it anyway. This is not like this problem over here because that's not a perfect square. The reason this worked out was because 9 is a perfect square over here. So we're just done with the question at this point. This is the factored form. And then this last one right here is actually kind of similar to the quadratic version we just did here, like multiply to get negative 9, add to get 0. So this is going to be multiply to get negative 49, add to get 0. The only difference here, this is quartic, so because this is x to the fourth, I'm just going to put the beginning of both factors as x squared, and then that's a perfect square. One of these is plus 7, one of these is minus 7. And of course, if you want to check, you could FOIL these back out, multiply them back out to make sure you get the original problem. those are the factored forms of each of those, and we're going to be using that today to solve some equations. These are just expressions, so this is just strictly factoring. We'll use this to solve some problems in an example down the way. Okay, now, in general, when you're solving a polynomial equation, so we've been doing this with quadratics, we did this a little bit with cubic functions, so just in general, the number of solutions is always equal to the degree of the polynomial, and that's just the highest power of x. So the number of answers you should have will always match that. If the solutions are actual real numbers, you can be looking at a graph and see those, they'll be x-intercepts. So that just means where the graph crosses the x-axis. Now, if the solutions are imaginary, and that can happen, we'll have to use algebra in some way to solve for them. It might be with factoring, it might be with the quadratic formula. So what I've got down here is just information about what happens if it's not really easy to see the answer. So if all the factors of the polynomial are not linear, okay, so what that means, a linear factor would look something like this, like an x plus 5 or an x minus 3 or something like that. A linear factor just has an x. And if you have that format, you can just set that equal to 0 and find your 0. So like if this was a linear factor, -5 would be an answer. If this was a linear factor, 3 would be an answer. If I don't have them in that format, you have to try to get them at least down into quadratic factors. Okay, now a quadratic factor, I'm just going to totally make something up. Like let's say I could get it down to x squared plus 2x minus 3 or something like that. At that point, maybe we could factor, probably not if we're using this to solve a polynomial. What we're probably going to have to do is use the quadratic formula. Okay, so if you're working with a quadratic factor, which you'll see this off and on today, what you want to grab is the discriminant and help you kind of figure it out, or you can just go through and do the entire quadratic formula. But I just want to give you a little reminder. I do have down on the page here, this is the quadratic formula just typed out for you. If you guys remember, the discriminant is the b squared minus 4ac, not including the square root, but just what's under the square root. And that can tell you a lot about what the solutions would look like. If that number is a positive perfect square, then you have two real, what we call rational, that means it can be written as a fraction, solutions. If the discriminant is not a perfect square, and let's say that it's positive, because we're going to deal with negative next. Sorry, I should have typed that in there. Okay, so positive perfect square, two real solutions. If we have a positive not perfect square, perfect squares are like your 1, 4, 9, 25, things that give you a nice square root. I don't know why I went from 9 to 25 when I should have put a 16 in there. Sorry. So perfect squares, those have a nice square root. So if it's not one of those numbers and it's positive, you have two real irrational, which means we're going to have to use the quadratic formula because we won't be able to see them nicely on the graph. Irrational solutions. Now, if your discriminant is negative, we're definitely going to have to use the quadratic formula. Well, not necessarily. We're gonna have two imaginary solutions, and we're probably going to have to use the quadratic formula. You'll see what I mean by that in the next example. But two imaginary solutions. Okay, now what I have at the bottom of my page here, these are just two polynomials. They're equations. Notice they're set equal to 0. These are already in factored form. So if you've already got this format, what you want to do is just set each one of the factors equal to 0. So what did you plug in for x that would make it 0? If you get one of these to be 0, since everything's being multiplied, it would make the entire equation true to plug that number in for x. So out here in front, if I just did, you just set any of these equal to 0. So if I have 3x, if that was equal to 0, that's wiping the whole thing out. If you divide both sides by 3, 0 is just going to be one of your answers. If I go right here x plus 2, subtract the 2. Now, if you guys remember, when we talked about exponents here, we don't want to multiply this out because we would like it in that format. But this means I have a multiplicity of 2, and that's going to matter in terms of how many zeros we have. So I have one answer here. This counts as 2 answers because it has a multiplicity. Right here, 2x plus 3, set that equal to 0. I'm going to subtract 3. And then I'm going to divide by 2, so another answer there, negative 3 over 2. Don't have any exponent. And then this last piece here, 5x minus 2, set that equal to 0. I'd add 2 and divide by 5. So my final answer is 2/5. So this question has 4 different answers. This one counts twice because it has a multiplicity of 2. Okay. Here, x squared, that is just going to be a 0, but again, since you have an exponent that has a multiplicity of 2, so that counts twice. This one is just going to be negative 6, and unfortunately here, we have a quadratic. This is not factorable any further. So if that's what you run into, you're just going to use the quadratic formula. So I've got that right above here. So opposite of b for this question, negative 6 plus or minus square root 6 squared, 4 times 1 times 3, and then all over 2 times 1. Okay, now, I usually just go ahead and do the quadratic formula, but I probably should have checked to do the discriminant here first. So I'm going to do 6 squared minus 4 times 1 times 3. That's going to give me 24. Which is not a perfect square. So I'm going to have 2 real solutions here, but they're going to be irrational. And then what I'm going to ask you guys to be able to do here, break down that radical. So 24, if you want to use a factor tree, you can totally do that. I just try to do the biggest perfect square that divides into it, which would be 4. So square root of 4 is 2. So that square root of 24 is going to simplify to 2 times the square root of 6. Okay, now, sometimes you can do this, sometimes you can. It depends on the question. Do not touch that radical. If all those numbers are divisible by 2, you can reduce this, just like a fraction. So the 6 and the 2 are both divisible by 2, so I'm going to go ahead and do that. So my other 2 answers here, this is going to become negative 3 plus or minus. Now, 2 divided by 2 is just 1. You're not going to typically see somebody write a 1 in front of the radical, but think about that being there. So the answer would be written like this, negative 3 plus or minus the square root of 6. And this is 2 answers because it's negative 3 plus the square root of 6, negative 3 minus the square root of 6. Now, we would be able to see all of these on a graph, but this one you're going to have to use a quadratic formula to get the exact answer. All right, now in this example I'm going to relate back to the very first thing that we were working on today, and this is factoring a quartic to get to our answer. So this is going to be, I'm going to multiply, this is 1 times 9, so I'm going to multiply to get 9, add to get negative 10. So for that we're going to use negative 9 and negative 1. And so I'm going to have, just remember, if you start out with a fourth, just make that an x squared instead of an x, minus 9, x squared minus 1. Okay, now there's kind of 2 approaches. If you want to continue to factor, you can. The difference between this and the very first set of questions we did is this is an equation. The first set of questions didn't have this equals 0. So from here I actually have to solve this. So 2 options. You can continue to factor, or you can just take what you have there and set that equal to 0. So if I do x squared minus 9, set that equal to 0, I would add 9. And then we'd take the square root. And then just don't forget, when you introduce the square root, you get plus or minus. And so that would be 3 and negative 3. Here, I'd have x squared minus 1 equals 0. So x squared equals 1 when I'd add that to both sides. Square root of 1 plus or minus 1. So you have 4 answers to this question, like, whoops, this is to the 4th power. So 3 and negative 3, 1 and negative 1. The other way you could do this particular problem, if you wanted to factor it further, This does factor difference of squares x minus 3, x plus 3. This factors x minus 1, x plus 1. And then you can just get your answers from the linear factors, 3, negative 3, 1, negative 1. So it's the same thing if you want to factor it further, or if you want to just solve from there, you can go ahead and do that. For this question here, I got to multiply to get negative 24, and I got to get add to get negative 2. So I'm going to do, let's see, I'm going to do negative 6 times 4. That's going to be the only set of factors that work. So x squared minus 6, x squared plus 4. And just going to take each of these, set them equal to 0. Now, neither of these can be factored any further than like the previous question. This is not a difference of squares. 4 is a perfect square, but this is not a difference. So you can't factor that further, and you'll see why in just one second. So for this, I'm just going to add 6 to both sides, and we're going to take the square root. Now, 6 is not a perfect square like it was in these previous questions here. So the actual answer, just go ahead and put plus or minus square root of 6. Now you would be able to see that on the graph in terms of like it would cross the x-axis at that spot, but it would be very hard to estimate the square root of 6 because it's going to be a decimal. If I grab my calculator here real quick, if I just, if I do square root of 6, you're going to see it's like 2.45-ish. You would see it cross the x-axis there if you were looking at the graph, but it wouldn't be going through like a nice number, which is why I'm using algebra to find that value. Now here, subtract 4 from both sides. Now remember, I can take a square root of a negative number, but it's going to have an I in it. So this is a perfect square in imaginary land, but it's not going to be something we would be able to see on a graph. So plus or minus 2i is how I would write that. Now, this question, x to the 4th, should have 4 answers. 1, 2, 3, 4. These you would not be able to see on the graph. These you would be able to see on the graph. Now, any of these answers we've gotten on any of these questions, if you want to go back and plug in like square root of 6 for x, that will make that 0. If you want to go back in, plug 2i in, and follow the properties for imaginary numbers for x, we'll get 0 back. Same thing over here. If you plug in 3, negative 3, 1, negative 1 for the x, it'll be 0 when you do that if you want to check any of these. Okay, now the last example here. This is where you're going to want either a graphing calculator or Desmos. So I'm going to pause the video just for a second so I can get Desmos up on the computer and kind of split the screen. Okay, now I've got my notes over here to the side, so I'll pull that back up in 1 second. So Desmos looks like this. It's just, I'll link this in the on the page there, but desmos.com, totally free. All you want to do, go ahead and click Start Graphing, and here's your graph. And I'm just going to pull this over really quick, and we can pull it back so I can go ahead and see what I'm graphing here. Now, I have this set equal to 0. I'm going to type y equals, all right, and then I'm going to type x, and then I'm going to continue this. It'll just type as I go, kind of transforming what I'm typing in. To get the third power here, I don't know how I can show this to you guys. You want to hit the shift key and the number 6. It's a little caret, so shift and 6. That'll be the third power. And then if you want to just use the arrow key to go over, that'll put it back down. And I'm going to do minus 5x, and then shift 6 to get the squared. Just arrow over, minus x plus 5, and I'm typing this in. Now, that's just the equation. We want to know when it's equal to 0. So that's going to happen across the x-axis here when the y value is 0. So I'm just going to stretch this back to the side so we can see the graph a little bit better. Now, you can literally move this graph with your fingers. You can do all kinds of things. It's being really slow this morning. I was just trying to move it so you guys could see a little better, and I think it's kind of registering my mouse. But what you're looking for is where does it cross the x-axis. Whoops. Okay, now I can literally click these points where it crosses the x-axis, and it will tell me the exact point. Now, we're only going to use this if these are exact numbers, which they are for this question, and I'm just looking for the x value. So the answers here, let me come back to my notes here, pull this aside so you guys can see the graph. Okay, so literally I'm done with this question. This is x to the third. This should have 3 answers. I actually have all 3 of them being real numbers on this question. So we would write down -1, 1, and 5. Those are our answers, and we're totally done with that problem. Okay, now the other 2 are not going to be quite as easy. So let me, Okay, so here's my next equation, and really I just need to change a couple things. Now this should still have 3 answers, so let me just go back and edit this. This was a -3, and this is a -2x. I'm just going to add a 2 in there, and then +6. So here's our new, this is our new problem here, -3x squared minus 2x. Okay, so I'm going to come here. Now, not a nice number, so we're not going to estimate that. Not a nice number. This, however, is 3. So what we're going to do here is we're going to use the 3. So I know 3 goes in. Let me come back here. One of my answers is 3. Okay, now if the other answers are not nice, it's going to ask for exact answers, so I'm going to show you how to do that. So let me pull this back through here. Okay, if I know an answer is 3, I'm going to come and have you guys use some skills we haven't used for a second. If an answer or a 0 is 3, the factor that would go with that would be x minus 3. So since I saw in the graph that went in, what I'm going to do is I'm going to divide to break down this polynomial into things that I can factor or solve. So this has to go into that polynomial. So I'm just going to use some synthetic division. So if this is x minus 3, this will be a 3. Write down your coefficients, 1, -3, -2, and 6. Bring this down. 3 times 1 is 3. That goes in the next open spot. This actually adds up to 0. 3 times 0 is 0. This is -2. 3 times -2 is -6. And this is what we would expect. You won't have a remainder because you know you have a factor. This is your remainder, your plain number. No x. This will be x squared. So here's what this means. The factored form of this, we know x minus 3 from the graph. The other factor is x squared, no x, so I'm not going to write that, and then -2. So those two things together to give me 0. 3, we already know that from the graph, and then all we have to do here is set this equal to 0. So I would add 2, take the square root, and plus or minus the square root of 2, that gives me the other 2 answers. Now, if you guys remember, let me pull the graph back just real quick. Okay, so this is estimated. That's why I went through and did that process, because I wanted an exact answer. But you look at these numbers, -1.414 and +4.14. Let me just show you on my calculator. Square root of 2. That's the number. Obviously, the graph rounded it, but that's where those values are coming from. Okay, and now we're just going to repeat this process just one more time. So I'm looking at my equation here. Let me pull back my graph. Alright, so I've got x cubed minus just plain x squared, so let me delete the 3. And then I've got minus 15x, so put a 15 in there. And then I've got a minus 25. And now, again, let me back up to this. You guys should see this is x to the third, so this equation should have 3 answers. Let me back up to the graph. Again, you can zoom out or zoom in. This crosses at one nice spot at 5. I'm going to make the graph a little bit. Let me see if I can show you guys this graph a little bit better. Okay, sorry, my computer wants to keep doing stuff that I'm not doing while I'm touching it. But you can't see another place where this graph crosses the x-axis. So that's going to mean that our other two answers, because we should have 3, our other two answers are going to be imaginary. Now just remember, we saw that this crossed at 5. Okay, so for sure I know one of my answers is 5, and that's going to correspond to the factor x minus 5. Now if I had gotten a negative answer as I'm looking at my zeros, it would be x plus that number. Okay, so we're just going to do exactly the same thing. I'm going to divide that in. So 5, write down your coefficients. 1, -1, -15, -25. 5 times 1 is 5. Add these guys together that are stacked up. This is 4. 5 times 4 is 20. This would be -5. 5 times -5 is -25. Or what am I talking about? This is 5. This is 25. Okay, our remainder should be 0 because we know this is a factor. Remainder number x squared. Okay, the factored form here, after I did the synthetic, I know the x minus 5 from the graph. X squared plus 4x plus 5. Now, I know that this is not going to be factorable because I saw the graph and I didn't see any other places that it crossed that were nice numbers. So what we're going to have to do here is use the quadratic formula. And I'm just writing quad form as an abbreviation. So one of my answers I know is 5. To get the other two, we're going to use the quadratic formula. Alright, so opposite of b would be -4 plus or minus square root 4 squared minus 4 times 1 times 5 all over 2 times 1, just focusing on the quadratic there. Okay, let me get what's under the square root. So we got 4 squared minus 4 times 1 times 5. So I have -4 plus or minus the square root of -4 over 2. Now, this particular case happens to be a decent because this is a perfect square in imaginary land. The square root of -4 is 2i, so I just have -4 plus or minus 2i over 2. Now, I don't have any radical left here, but if you can, all these numbers are divisible by 2, so you go ahead and reduce that. This is going to be -2 plus or minus just a plain I, and those are going to be your other two answers. And they're imaginary, which is why we weren't able to see them on the graph.